Yeah, so a recap of what we did, we're just converting from exponential form, then we're giving the logarithmic form of that particular expression. So for example, if you have y is equal to b to the power x, we said this can be changed to be log y to base b is the same as what, x. Then I told you to say whenever the base is not given, we're always going to be assuming it's a 10. So if I give you something like log, then I have, let's say 8 is equal to x. There is no base here, so you assume that the base is 10. You can rewrite this as 10 to the power x is equal to 8. So this is the same as 10 to the power x is equal to 8 when you write it back in exponential form. This is what we were doing last time. Now, I also gave us the expression for the natural log to say if you have y is equal to e to the power, let's say x, this is the same as you just saying log y to base e is equal to what, x. That's what you have. This is equal to x. This is equal to x. Now, this part here that we call log, the base of e, it's the same as ln. So we can just say ln y is the same as what, x. Whether you write it as like here, the way we've done it here, whether you write it like this or write it the way we've done here, it's the same meaning. We just say whenever the ln expression is used, the base is always going to be e. Yeah, so this is what we mean by the natural log. And this is important. It's going to play a very important role. If I give you something like, let's say 2 to the power x is equal to 3, for instance, you are unable to make 2 and 3 to be the same bases, because if I was to give you 2 to the power x is equal to 8 to the power, let's say the power 1, this is what you're having. You can change 8 to what? To base 2, right? This is going to be 2 to the power x, then this will be 2 to the power 3. You know, you're able to change. The bases are the same. You just say x is equal to 3. So this is what you would have done. Now, what if we cannot change, or rather make the bases to be the same? Look at this here, you're having a 2, here you're having a 3. So you can introduce the natural log, or just log on both sides. So here you would have just done the introduction of log this side. You also introduce log in front of the 3. So you have log 2 to the power x is equal to log, this is a 3. The x can come down this side. There's a rule, remember, there's a rule that says if you have log a to the power n, this here is the same as n, then you have log a this side. So that's why we're saying the x is going to come down. So the x comes down this side. So this is the same as x log 2 is equal to log 3. So here, let me just erase this. Then here having a log 3, you can divide with a log here, log 2, also divide by log 2 there, meaning x is equal to, you have your log 3 there on top, then you have your log what? Log 2. You know to say, because there is no base here, the base is just going to be assumed to be a 10. That's basically what we have. Yeah. So this is the importance of learning natural log or other logs, because we're able to solve things when the base is not the same. So a recap on the rules. So the rules that we gave was, we said whenever you have log of anything to itself, the answer is just 1. We also said log of anything, log 1 to base anything, the answer is 0. Then the third one, we said log of anything to the power, let's say this, log of b to the power n to base a is just the same as log of b and a. We can just take the power back this side down. So this is what it means. We said if you have log, the bases are the same, then these guys are adding. This is just going to be the same as log, then a, you just multiply a and b. Then if it's subtraction, provided the bases are the same, this is just going to be the same as log of what? This is just the same as log of a. Then you just say a over b. This is basically what you have, provided the base is the same. Then the next one, we also apply to ln. Ln is the same as log, just that it's log with base e, right? That's the same as ln. So when you say ln a to the power n, it also applies. The n can come down. That's the reason why we saw something like this. It can be that. Then apart from this, you can also have, so all the rules for log also apply for ln. It's just that ln has the base e. So if it's plus, it's the same as ln of a times b. The same applies to the minus. If you say ln of a minus ln of b, this is the same as ln of a over b. The same thing also applies if you have ln of 1. This is also a 0. Then again, ln of e. So this is I and h. So, I mean, I and n, I mean, not h. Yeah, in number 5, we're just saying ln of e is equal to 1. Why? Because there's an e there. This is equal to 1. Remember we said log a is what? 1. Provided the base and this guy is the same, the answer is 1. Because e to the power 1 is the same as what? E. A to the power 1, that's how we get your what? Your a. So these are some of the rules that we looked at last time. This is what I just wanted to give you a recap on. Now, the focus of today is going to be solving equations like number 7. That's what I want to show you today. Yeah, so we are doing logarithmic equations. So this is the focus of today. This is what we are going to do. Yeah, so we'll start with number 1. We'll make this guy to be our number 1. So this is 2 to the power 2x. So this is 2 to the power 2x. Here I have 3. There's plus 3. This is plus 3. 2x. Then this is a minus 4. Minus 4 is equal to 0. So call this as example 1. So the first thing that you do here is to identify the part that you're going to isolate. So it's always going to be evident, or you are always going to be finding it easy, or rather identify it easily just by looking at the whole expression. So the only weird thing that we have here is 2 to the power x. So meaning, even in here in the first expression, you are seeing 2 to the power 2x, right? So we can just write it as 2. We factorize 2 to the power x, and then put the 2 alone down. 2 times this is still the same thing. Then this is plus 3. Then this is 2 to the power x. Then this is minus 4. This is equal to 0. So from here, we're saying we let any letter, we can let k be equal to, let's say 2 to the power x. So wherever there is 2 to the power x, we'll replace with k. So we're going to get a k, which is raised to the power 2, then plus a 3. There is a k, then there's a minus 4, which is equal to 0. This will just be k squared plus 3k, then minus 4. This is equal to a 0. Then from here, we can just solve this. This is just going to be product. Product is negative 4. The sum is simply 3. The factors, what factors can we use here, guys? Okay, so we're going to use, we use negative 1 and 4. So if we do the replacement here, this is going to be k squared. This is plus 4k, then minus k, then minus 4 is equal to 0. This will just be a k. Then here there is a k plus 4, then minus 1. This is k plus 4 is equal to 0. So this is going to be a k plus 4 and a k minus 1. This is giving us a 0, implying that k is equal to negative 4 and k is also equal to a 1. Now, whenever you get these answers, these are not the final expressions that we want. The question had x, not k. So we need to get the value of the value of x. So remember that k is the same as 2 to the power x. So we're going to let everything go back to what it was. So 2 to the power x is equal to -4, or 2 to the power x is equal to a 1. So whenever you see a negative base like this 4 here, this guy here is -4, right? So we cannot change a negative number and become a positive number. In short, logs do not accommodate negative numbers. So we are going to discard this expression here. We discard it. We throw it away. Then this side here, we know what 1 can be changed into. So 1 is the same as, this is 2 to the power x is the same as, this is the same as 2 to the power 0. So this is the same as x is equal to 0. So this is the only answer for this question that we're from solving. X has to be equal to 0. Any questions, guys, up to this point? Okay, so if there are no questions, then we can go to the next one. Look at the next one here. This is a little bit interesting. So we're having 3 to the power 2x plus 1. So I'll just copy it down here. So example 2. So it's 3 to the power 2x, then plus a 1, then minus 26. This is 3 to the power x, then minus 9 is equal to 0. So what they want us to do here is the same thing like what we're from doing. And like I said, there'll always be a hint in the question regarding what to do. Yeah, so what we are looking for is 3 to the power x. That's a weird thing. So we have to break this guy down. You remember under indices, you said x to the power n, multiplying x to the power m can just give you the same thing as x to the power n plus m, right? So it's like we're given this at this stage. We just have to break it down. This will be 3, 2x, then multiplying 3 to the power 1, minus 26. Then you have a 3 to the power x. Then this is just minus 9, which is equal to 0. Then from here, we're simply going to break down this. The 3 to the power 2x, we can factorize the 2 outside so that we have 3 to the power x. Put the 2 here. Then there's a 3 to the power 1, which is just a 3. I'll write the 3 in front there. This 3. This is minus 26. There's 3 to the power x. Minus 9. This is equal to 0. The weird thing is 3 to the power x, so we'll let it be equal to k. So we're going to say k is equal to 3 to the power x. So that this is going to be 3. This is k squared, then minus 26. There's a k, and minus a 9 is equal to 0. This will be 3. K squared minus 26k minus a 9 is equal to 0. So at this particular expression that you are given, yeah, so we have already replaced our 3 to the power x by k. So this is where we have formed the quadratic here. So the quadratic is your 3k squared minus your 26k, then minus your 9 is equal to 0. So the product is simply 3 by 9, which should be negative 27. Then the sum is just negative 26. So the factors that we can use in this case will be what? Is it negative 27 and a 1? They will give us, if we multiply them, they give us this. We add them, we get this here. So it's going to be 3k squared minus 27k, then plus a 1. This is plus 1k, then minus 9. This is equal to 0. We can just factorize the 3k there. So we're just going to have k minus. This is 9. We have plus 1. This is k minus 9. This is just 0. You have 3k plus 1. And you have k minus 9, which is equal to 0. So you have k is equal to negative 1 over 3. And k is equal to 9. So you have these two answers. And then you bring back your 3 to the power x. Yeah, so remember that we are looking for x, so 3 to the power x is equal to negative 1 over 3. So we said, provided the answer you've gotten is negative, you discard what you have, because logs do not accommodate negatives. There is no way that we can change negative 1 over 3 to be base 3. But if we have 3 to the power x is equal to 9, we are able to change the 9, because 9 can be expressed as something in base 3, which is 3 to the power 2, right? Then the powers can be equated, so this is going to be the solution. This is how we find the answer to this expression. Is this okay, guys? Fedson, this is okay, right? Am I too fast? Oh, okay. So the next example here, which is the last one, this part here, yeah, they want us to solve this. So I would like you to first of all attempt it before we even go through it. Yeah, just think about how we should do this. For those who will be watching the video, you can pause it and then try to attempt it. Yeah, so they've given us, so we have example 3. They've given us 4 to the power x. Then this is minus 6. Then we're having 2 to the power x. So each particular question is always going to be having a hint on how you can go about it. So this is what you have. You notice it's the same thing. The format is always going to be giving you something that will be acting like a guide. So here there is 2x. You are seeing the 2x. So meaning even here we know this is the same as 2 to the power 2. That's 4, right? There's an x there. Minus 6. This is 2 to the power x. Minus a 16. This is equal to 0. Then from here we just say 2 to the power x. Then we're having a 2. Minus 6, this is 2 to the power x, then minus a 16 is equal to a 0. Then this is simply going to be the same as, we do the replacement here now. You let k be equal to 2 to the power x. So here you put your k, here you put your k. This is going to be k squared minus 6k minus 16 is equal to 0. The product sum factor thing that we can do, we're just going to say we'll have what? We'll have k squared minus 8k, then plus 2k, then minus 16. This is equal to 0. This will just be k, then you have k minus 8, then this will be plus 2, k minus 8, this is equal to 0. We're having k, then plus 2, and you have k minus 8 is equal to 0. We're having k is equal to negative 2 and k is equal to 8. So remember that 2x was k, right? So 2x is equal to negative 2. We discard this. Whenever it's a negative, you discard it all the time. You only take the one that is positive. So this is, it's possible to put 8 in base 2, right? Because this is the same as 2 to the power 3. You just do this all the time. Write your number, which is 8. Put the 2 there, which is a 4. Put the 2 there, which is that. Put the 2, this is a 1. So you need to multiply 2 3 times. So the answer is simply 3. So x is equal to 3. 2 has to multiply itself 3 times for us to get our x. So this is basically what you do whenever you are given an exponential equation. Any questions, guys, here? Is this okay? I'd like you to just look at this first one here, this first one in particular, this guy here, the first one there. They are saying, it's almost similar to the one that we are from solving, because they are saying solve the following equation. So this is 3, so if I may do it for us here, this is a 3. So this is from last year's test 2, so example 4. Is from the 2024 test 2. So they are saying 3, there's 2x plus 1 is plus 10, I think, is equal to, then this is 10, or there's a 3 here, right? There's a 3 here, please pardon me, there's a 3 here. Yeah, so there's a 3 here, then this is 10, then you have 3 to the power x. Yeah, that's what you have. So first of all, do this, break down what you have here still, so we can just break it down. This is just the same as 3, 2x, then multiplying 3 to the power 1 plus 3 is equal to, there's a 10, 3 to the power x. Then from here, we know to say we're looking for 3 to the power x. Yeah, so here we're going to have 3x, which is, there's a 2 there, then there's a 3 plus a 3 is equal to 10, then 3x. Yeah, then from here we can just let k be equal to 3 to the power x, so that if we put a k here, it's going to be k squared times this 3, so the 3 can now be written in front, then plus a 3 is the same as 10k. We turn this into a quadratic by bringing the negative, the 10k on the other side, it becomes a negative. Yeah, this is what you have. Then here we just do what we are doing. The product is 9, so we're having negative 10 here, so have negative this. What will be the factors here? What factors can we use here? The product is 9, the sum is this. So what factors can we use? Negative 1 and negative 9, right? Negative 9, then minus this, then this is plus k is equal to 0. This will be 3k, you have k minus 3. Minus 1, there's a k minus 3 there. This is equal to a 0. This is just 3k minus 1, and you have a k minus 3 is equal to 0. Solve this, k gives you 1 over 3. Solve this, k gives you equal to 3. So we equate both of these to 3 to the power x. So 3 to the power x is equal to 1 over 3, which is the same as 3 to the power x is the same as 3 to the power negative 1. So x is equal to negative 1 for starters. The next one is this part here, 3x is equal to 3. So meaning x is equal to what? 1, right? Because the power here is 1. So meaning you get 2 answers. That's how the question was supposed to be done. This is what came in the last year's test 2, the first one on equations. Any questions, guys, here? Is there anyone who has any question? Before we solve this other one here, you see that they were both costing 4 marks each. So meaning what we are doing is actually always going to be there, and it will be best that you know how to manipulate it, manipulate the rules. This is there's log x, then this here to the power 4. That's a question. So the first thing that you need to do here is to first of all realize that when you write something like this, the first part here, it simply means this is the same as log of x to the power 8, right? The expression, how can I say this? The expression has, the 8 is simply on the x alone. It's not going to affect everything altogether. Yeah, but here this side, you notice that this side we're having the 4 is outside, right? Outside the whole thing. Yeah, so there's a big difference. So the main difference here is that the 8 is only on the x. I mean, the x is just on the 8. Here the 4 is for the whole log x thing. So for the first part, we can bring the 8 on the other side. This is going to be log x is equal to, this is a log x to the power 4. So meaning I can let my k be equal to log x. So wherever there is log x, I'll put k. This will be 8k is equal to k to the power 4. This here is going to be the same as k to the power 4 minus 8k is equal to 0. And from here we can factorize k. You have k to the power 3 minus 8 is equal to this, meaning k is equal to 0, and k3 is equal to 8, which just changes and becomes k is equal to 2. We cannot accommodate the negative one because you not say the root of 8, the third root of 8 can either be plus or minus. So here we're just going to say we're having this guy, and also we have this. So now we equate them to log x. So log x is the same as 0. So if there's a 10 here, 10 to the power 0 is equal to what? 1, right? So x is equal to 10 to the power 0. So x is equal to 1. That's the first answer. The next one, we do log x is equal to 2. So say log of x is equal to 2. There is no base, so we assume the base is 10. So 10 to the power 2 is equal to this. So x is equal to 10 to the power 2. That's simply the same as 100. So these here are your two answers. You have a 1 and 100. Any questions, guys, here? Is this okay? Okay, so if there are no questions, I'll just give you this task here. So try to see if you understand what we've done. Try to solve this expression here. Let's say what you get, 2 to the power x, then plus 2 is equal to a 0. Yeah, so you can just try this as a task. Find the value of x. So find values of x.